In this video, I'm going to work out a differential equation, and going one step farther than I have in the previous videos, we'll find that general solution, and then we will go one step farther and find the particular solution through the given point 0, 2, and then we will even compare it to the slope field so that you can kind of get a feel for the connection between the slope fields and the differential equations and then the solutions. This is part 3. Alright, of a series that I have on differential equations on my website. Okay, so here we go. We're going to solve for y given that my dy over dx equals x squared y, and we know the point y sub 0 equals 2. Alright, so I am going to start with this differential equation, and I'm going to separate the variables. I'm going to put all the y's on the left and all the x's on the right. So, rewriting the equation here, dy over dx equals x squared y. Alright, I'm going to multiply both sides of the equation by dx. Alright, when I do that, the dx's fall out on the left hand side, so this is my separating of the variables. So then I'm going to have a dy is equal to x squared y dx. Alright, now I still have the y on the right hand side. I need to get that over on the left hand side, so I'm going to divide by y. Divide by y, they're going to cross out over here, and divide by y over here. Alright, now I do want to clean this up a little bit so that when I integrate it, it's going to make a little bit more sense there. I've got that imaginary 1 on in front there, so I'm going to write this as 1 over y dy is equal to x squared dx. Alright, so now I have completely separated the variables. Okay, next step would then be to integrate both sides. I'm going to indicate that in red so it kind of stands out there a little bit. Alright, when I integrate 1 over y dy, I'm going to have the natural log, absolute value of y. Alright, integrating on the right hand side, that's going to be an easy one we can do. Add 1 to that exponent there, so we'll have a 1/3 x to the third, and then I'll put my plus c right there. Okay, now next step you're going to have to do, remembering that when you have a natural log here, you're going to want to go into exponential form. Alright, if you need to see it, you can put the little imaginary e right there so you can kind of see the base. It's going to be e raised to the 1/3 x to the third plus c equals the absolute value of y. Alright, so I'm going to go into exponential form. Alright, and I do want this absolute value of y on the left hand side, so I'm just going to go ahead and write it that way. It'll save rewriting. Absolute value of y then is equal to e raised to the 1/3 x to the third plus c. Alright, and again, let's identify what we did right there. Shorthand notation maybe, we went exponential form. Okay, now from here I want to apply my laws of exponents. I've got a base here that is raised to an exponent that has been added, so I can recall laws of exponents. When multiplying like bases, you add the exponents. So I can undo that law and separate this out. Absolute value of y is equal to e raised to the 1/3 x to the third times an e to the c. Okay, and then you can check that going back, multiplying like bases, add those exponents, I would get back up to here. Okay, so in that step then, laws of exponents. Laws of exponents. Okay, now from here I'm going to want to kind of get rid of that e to the c. Alright, e raised to some constant, that's going to give me a constant. I want to define that, so I'm going to let k equals e to the c. Alright, so it's going to kind of clean up my answer there. Alright, we're going to come up here. Alright, and now I'm going to rewrite that. I'm going to have absolute value of y is equal to, I'm going to put my k in front so it looks like a coefficient. So I'm going to have an k e to the 1/3 x to the third. Alright, I need to completely solve for y, so I need to get rid of those absolute value bars so I can add a plus minus to the other side. So I'm going to have a y equals plus or minus k e to the 1/3 x to the third. Alright, now at that point right there, I have a general solution. Alright, and in the previous videos in part 1 and part 2, that's as far as we went. Okay, so there is the general solution. Alright, now in this video I want to go a little bit farther. Alright, I've got this point y sub 0 equals 2. Alright, so that I know that fact, then I can plug that in and find out what my k is. I can determine, well, is it really a positive k or is it really going to be a negative k? Alright, so let's indicate that we're doing that here. Let's say using y sub 0 equals 2, find k. Alright, so that's what I'm going to get ready to do here in this step. Alright, so I'm going to plug 0 in for x. I'm going to plug a 2 in for y. So I'm going to go 2 equals. Alright, at this point I'm going to just go ahead and drop that plus or minus k. I'm just going to put a k there because once I get this all solved, it will be obvious that k is either positive or it's negative, whichever it turns out to be. Alright, e raised to the 1/3 and then 0 to the 3rd power. Okay, alright, so 0 to the 3rd power is 0. Anything raised to the 0 power there is going to be 1. So basically, this all goes away, alright, leaving my value of k being that positive 2. Alright, so let's actually do that. So k equals 2. Alright, now that I know that what my k is, I can plug my k back into this general solution and come up with a particular solution. So I'm going to have y equals 2 e to the 1/3 x to the 3rd as my particular solution. Alright, now what I like to do next here is I'd kind of like to take a look at the slope field. Alright, I've already generated the slope field, okay, in this picture right here. Let's see if we can just add that right there. Alright, this is the slope field for this differential equation. Alright, and if I indicate that 0, 2 point is right there. Alright, and then kind of draw the curve the way the slope field is indicating, alright, then this should represent my solution, alright, through 0, 2 of this differential equation. Alright, well, let's see if it does. Yeah, I can come back here. This is my particular solution right here. Okay, now, an e to the x curve. If you've got that one memorized, e to the x basically goes through 0, 1 and just kind of goes up like that. Okay, that would be a general e to the x. Alright, now this curve is kind of doing that. I've got this little squiggly tail on here. Alright, but this is not a plain e to the x. I've got the 2 in front there, but then that exponent there, alright, 1/3 x to the 3rd, alright, that is giving us our little variation. But hopefully, knowing your family of curves, if you know e to the x is like this, then yes, this is going to represent this particular solution. Alright, so there's your connection to your slope field and then your solution to your differential equation. Alright, so in this video, I think to keep it short, we're just going to go through this one example. Alright, if you like the video, go ahead and give me a like, and if you're finding that you're liking my explanations, then go ahead and subscribe to my channel so you'll know whenever I add new videos. Thanks.